hoping actually that this will take place. On the other hand, many TLDs and many CC-TLDs have not announced what they are going to do with their zones. For instance, the Dutch registry, SIDN, is thinking really hard about DNSSEC, but they still have some operational issues with that, so they haven't announced anything, and I'm sure that's true for many of the TLDs in your countries as well. So let's go back to the question, how can I validate the answer that I got when I queried for www.nist.gov? Well, the NIST.gov zone has been signed. I hope you can read it, but I'm going to talk you through it anyway. The NIST.gov zone has been signed using a private key, and the public key has been published in the zone. And actually what they have done is that they have supplied a hash of this key that they use to sign to their parent domain, which is the .gov domain. And what .gov will do is they will publish this hash in their zone, and then they sign their zone as well. So what they're saying is, we really trust NIST.gov because we actually assert that this is the key they use to sign their zone. So instead of every resolver having to negotiate trust with NIST.gov and with whitehouse.gov and with whoever, they can just decide to trust the US government and trust the .gov domain. Now, what would be really convenient if the root were also signed, because then the root could say, hey, we trust the US government, they use this and this key to sign their zone. So actually all I need to do is trust the root, and I only need to trust one set of keys to express trust in the complete DNS infrastructure. Now, unfortunately, the root hasn't been signed yet, but if that happens, that becomes possible. Now, because that hasn't happened yet, at the moment we are faced with a situation where we have islands of trust. The areas marked yellow in this picture are changed that are signed. .org is signed, .gov is signed. Well, SurfNet isn't actually signed, but I needed an example. So the top of these chains, we call those trust anchors. So at the moment, if I want to validate DNSSEC answers, I need to know all these trust anchors. I need the key to know the public key for .org. I need to know the public key for .gov. So how do I find these? Because if I want to be secure today, and if I want to validate the signed answers that I get today, what do? Well, I need to find these trust anchors. And as it turns out, it is really hard to manage these by hand. And some people have tried to help us along, because IANA has made HAR available, which is a set of trust anchors for all the top-level domains that have signed their zones. And ISC, which are the people behind the bind name server, have introduced something that they call DNSSEC leukocyte validation, and that is actually a repository that that you can submit your public key to, and that a resolver can query. I'll tell you a little bit about that in the next slide. Now, the problem with this is that there is no standard way to trust these repositories. For instance, you can see IANA has secured their site using SSL, HTTPS. So if I trust SSL, and if you heard Dan's talk yesterday, that's a bit questionable, but if I trust SSL, I can use that to trust the information that I get from IANA and the ITAR repository. ISC is actually using DNS for the leukocyte validation, so they're using a DNS server themselves, and I need to trust the key that they use to sign this DLV domain. And actually, I need to download this from an unsecured website, and I need to check a PGP key that is on there. So that makes it, and remember, these keys all have a limited validity. They are either valid for maybe a year, or in case of a certificate, maybe 3 years. But after that time, I will need to download new trust anchors, because either the trust anchors have expired or the trust on the trust anchor repository has expired. And I need to keep up to date if I want to stay validating. Now, the good news is that these are all interim solutions. Once the root is signed, hopefully we won't need these anymore. Now, just a little bit about DLV. They put the public keys at the top of the trust chain, so the trust anchors into a repository, And actually, if a resolver wants to query a domain and it wants to validate the answer on that, it can ask the DLV, well, do you have a trust anchor for this query that I have? The downside of that is that ISC actually receives all the queries that I do on my resolver, which is a bit of a privacy issue. So keep that in mind if you want to use DLV to validate DNSSEC answers. Now, I made this nice slide with lots of colors for some of the managers within an organization. And what you can see is that, well, this is a standard graph that anyone can use. It shows you where we are now, 2009. I hope you can see it. Is somewhere over there, and we are in the early adopters phase. But actually, I'm a little bit more optimistic at the moment, because this year, many people have started working on DNSSEC. Suddenly, people are saying, hey, we're going to sign the root before the end of the year. And VeriSign is going to say, well, we are going to sign .NET and .com. So actually, I moved 2009 a little bit forward, and I'm a little bit optimistic about where we are now. I'm sure not everybody shares my optimism, but hey, hopefully it's going to happen a little bit sooner. Now you're going to ask me, is there no criticism on DNSSEC? Well, Bert, who gave a talk yesterday, has been very vocal critic of DNSSEC, and he said, well, DNSSEC, it's the string theory of the internet. It has a cult-like following. It will be ready in 6 months, etc., etc. And, well, really, it is something nasty and it's horrible and it's hard to do. And actually, he's right. DNSSEC is hard to do, but even the critics agree that DNSSEC is the only solution available at the moment to mitigate attacks on the integrity of the DNS. Now that doesn't mean DNSSEC is perfect, and it's really hard to do because you need to manage keys and you need to roll your keys when they expire, and you need to talk to your parent domain, which there are no standards for at the moment. So it's really hard to do, and actually if you mess it up, your zone disappears from the internet. So your domain could disappear, which is really, really nasty for people, because at the moment DNS, although Bert said it's really hard to implement, once it's been implemented and when you are operating it as a system administrator, DNS is actually very forgiving, because you can make lots of mistakes before your zone actually goes down off the internet. Now I'm also responsible within SurfNet for our DNS infrastructure. And I have a lot of our connected institutions who make small and larger mistakes. Some of them have actually blocked both UDP and TCP on their authoritative servers, and which basically means that no one can reach their authoritative servers, but because we run a secondary for them and they allow us to do transfers, their domain is still on the internet. And I have a really hard time explaining to them that, well, DNS is a public thing, so you should expose your servers to the rest of the world. And they say, no, that's not safe, we can't do that. So DNS is very forgiving because there is this redundancy built in. And with DNSSEC, because it is much harder to manage, I can break it more easily. And if I do that, that will lower the acceptance of DNSSEC. And actually, it will be dangerous because it's a dangerous tool in the hands of people who don't know what they're doing. So, in my opinion, what is really stopping DNSSEC from being rolled out on a large scale is good tools. Because actually, if you have a tool that you can tick a box that says, well, turn on DNSSEC for my domain, and I don't have to worry about all this key stuff, and I don't have to